same. I'm not changing anything, not changing any of those steps, right? Those steps that we've been using for all of these problems, you're still doing those same 6 steps. Sometimes we got to do step 4. I think with these last 2, we're going to have to do step 4, which is we have to use another equation. Sometimes when you're trying to find area, you have to use perimeter equation to find it, or was it circle? I didn't put circle up here. Circle is one I should put up here. When you're using circle, sometimes you're using area, you're trying to find area, but you have to do circumference, right? Like we did on the very last problem. Oops, there's 2 number 9s. The first number 9. So when we were trying to figure this out, there was questions about circumference, right? But we didn't have enough information to plug in everything. So we had to use area to figure out dr dt, right? We had to do that. Sometimes you have to do that. That's the extra step sometimes. That's that step 4 that sometimes we do and sometimes we don't. Okay, so this should be example number 10. Okay. All right. Okay, so right now what I want you to do, what do you know? Read the question, underline, highlight, write down, what do you know, and what are we trying to figure out? Okay. What do you know and what are you trying to figure out? So this is a cube. We haven't seen a cube. We've seen cylinders, we've seen spheres, we've seen 2-dimension objects, right? Rectangles, squares, triangles, circles. We haven't seen a cube, but a cube works the same. It doesn't matter what the shape is, right? So it doesn't matter what the shape is. It's just we do the same steps. Different formulas we're going to use, but on the test I'll give you all the formulas. Any formulas you need for shapes, I will give you those formulas. So you don't need to memorize any formulas or anything. Okay? So what do we know about this? What do we know about our situation so far? We got a cube. What do we know about the cube so far? So the volume is increasing, right? So 88 cubic meters per second. What tag are we going to give that guy? dV over dt, good. Increasing, so it's positive 88. Good. So the volume is getting bigger. So the cube is getting bigger. Volume is how much stuff can the cube hold, right? If it's a cube of ice, how much water is the ice holding? Okay. What else do we know? So the length of the cube, right? A cube, what's special about a cube? A cube, all sides are equal. Every side length is equal. So every side length that you see is 2. So we'll say x is 2. X is 2 meters. Oops. Okay. I think that's all we know. Now, what are we trying to figure out? So now we're trying to figure out something called surface area. Surface area. Okay, so before we go and do the problem, surface area is if this was let's say this was a cardboard box, just a closed cardboard box, right? Like you're packaging it up to give to someone or to deliver out, right? You're taking it to UPS or wherever, and you've sealed it up, and it's just a cube. What surface area is how much wrapping paper would it take to cover that thing? That's what surface area is. Surface area is how much area is on the surface. 2 dimensions, right? Area is just 2 dimensions. So essentially what you're doing is you're finding area of each side, right? So let's see. This is not a cube. This is not a cube. This is a rectangle. But it's how much wrapping paper would I need to wrap this perfectly, right? So you have this side here, right? This is your length. This is your length. This is your width, right? Same thing here. Same thing here. Same thing here, right? So it's got 6 sides. It's got 1, 2, 3, 4, 5, and 6 sides, right? That's where the 6 comes from. And you're just finding area of each of those sides. So that's where x squared comes from. So that's what surface area is. Surface area is for a 3-dimensional object. It's like if I wanted to wrap it in wrapping paper. Or if you want to paint it. If I wanted to paint this, right? If I wanted to paint, how much paint would I need? I need to paint the top, the sides, the bottom. That's what surface area is. Okay? So we have to figure out what is the rate of change of surface area. Okay, so since surface area is SA, we're going to say dSA over dt. That we don't know. That we do not know. Since the question is asking about surface area, we're going to use the surface area equation, formula. Right? Surface area is equal to 6 times x squared. Okay? So the first thing we got to do, we have our equation, or formula. Differentiate. Derivative. dSA equals, and then we find the derivative of 6x squared. That's 12x dx over dt. Plug in what we know. We don't know dSA over dt, right? We don't. That's what we're trying to figure out. That is the reason we're doing this problem. This is the question. So it makes sense that we don't know what it is. And we have 12. X we know is 2. What is dx over dt? Do we know what dx over dt is? We don't, right? So this one's kind of like the question we did at the end of yesterday, right? Will we try to plug in things and we're like, uh-oh, we don't have one of the pieces. So what did we do? We used another formula that goes with this guy that would help us, right? Which other formula for a cube could we use that would help us figure that out? What other formula for a cube is there? Volume, right? Volume of a cube is x cubed. X cubed. Take the side, multiply it by itself 3 times, and you get the volume. So now what we got to do is we're going to differentiate that because that'll give me dx dt. Okay. So dv over dt equals 3x squared dx over dt. I know what dv dt is. They told me, 88. I know what x is, 2. I don't know what dx dt is. I can solve for it, though. If you know what everything else is, you can solve for it. Okay. So 88 equals 2 squared is 4 times 3 is 12. Divide by 12. Now it doesn't go in evenly, but we can reduce it. I think you can divide both of them by 4. So you get 22 over 3. We're not going to round it. I'm not going to divide it until the very end. I'm not done with my question. All I did here was give me what dx dt is. So now I can go plug it in over here. 22 over 3. Okay. So I got 24. When I multiply these two guys, I got 24, or 24 over 1, and 22 over 3. Well, the 3 and the 24 will cancel out. 8 times 22, well, 4 times 22 is 88, so double 88. 176, I believe. Let me double check to make sure. Yeah, 176. It's an area. So it's going to be meters or centimeters. Oh, wait, I totally missed something. No, I didn't.
It said cubic meters at the top.
Yeah, I did say cubic meters. So yeah, I put centimeters here. It should be cubic meters, right? Make sure I don't have, because I put centimeters up there. So I thought we had to convert it, but it doesn't look like we have to convert it, right? Okay. I put centimeters because I saw cubic meters, cm. So I thought one of them was cm and one of them was m. So as long you have to make sure that all of your units are the same. They believe they're the same. So good. Okay, so meters squared over seconds. Because I've seen them do that. I've seen them do that on questions like this, on FRQs, and on multiple choices. This is what they'll do. They'll say 88 cubic centimeters. Like they'll say one of them's in centimeters and the side length's in meters. So before you do any kind of calculus, you have to convert them. So yeah, so always double check to see, because I've seen them do it. They don't do it a lot, but I've seen on some questions where they'll say this number is in centimeters and this number is in meters. So before we do any kind of math, we need to make sure that they're both the same units. They were, but like I said, sometimes they'll throw that little wrench in there and they'll say one's in inches and one's in feet. So that means before we do any kind of math, we have to convert them to make them the same. But luckily they're all meters. Everything is meters here, so we're good. Okay. All right, one more. Last one. So we have another surface area. This one's a sphere again, so we've done spheres. Okay, so write what you know, write what you need to know. So always start out that way. First thing you're going to do is write down what you know, write down what you need to know. So we have a list so that when we start solving the problem, we know where to go. So on the notes I posted on Google Classroom, the last thing on the last page is all the formulas from there. Like I said, you don't need to memorize them. I'll give you any formulas that you need on the test. On any test I give you, I don't want you to memorize formulas. It's pointless to memorize formulas because you can just look them up. So that's not one thing that I'm worried about. So any formulas you need on the test, I'll give you. I'll just make a list. I'll make a list like that. I'll probably put something like that on test day, and then so anything that you need will be up there. Okay? So the volume of a sphere is decreasing at a constant rate of 131 cubic feet. Okay? So volume, right? dV over dt equals, it's decreasing, negative 131 feet cubed per second. At the instant when the radius is 2 feet, r is 2 feet. What is the rate of change of surface area again? So they're asking us about surface area. So dSA over dt. I think that's all we know. Yep, that's all we know. So what is the question referring to? Volume or surface area? Surface area. So that's the formula we need to use. So that's the one we're going to use. So even though they gave you both, the one we're going to use right now is surface area. I'm not saying that's the only one we're going to use, but that's the one that we're going to start with. Always the one where the question revolves around. Okay? Derivative? 8 pi r dr dt. Because remember, pi is not a variable, so we don't treat it like a variable, we treat it like a number. So dSA over dt, 8 times pi times r times dr dt. R is 2. We know r is 2. But we don't know dr dt, right? That one we don't know. Just like the last two problems, we don't know that guy. We don't know it right now. So when you have something like this, that's when we're going to use the other formula. That's why they gave us another formula. So what we're going to have to do is use volume to figure out that part. So we're going to have to use the volume formula. to figure out what dr dt is. Okay. All right. So differentiate. Move the 3 to the front. Subtract the power. dr dt. I know dv dt, negative 131. 3 over 1 times 4 over 3 is 12 over 3, which is the same thing as 4. R squared dr dt. We know r, it's 2. I don't know dr dt though. Well, I only got one missing part. One missing part I can solve for. 2 missing parts I can't solve for. One missing part I can. So in this one I can't. So it's going to be negative 131. 2 squared is 4 times another 4 is 16 pi dr over dt. Divide by 16 pi. We get dr over dt equals negative 131 over 16 pi. Remember, we're not gonna round any answers until the very end. So that number right there, literally that number there, I'm gonna put in. I'm gonna take over to the other equation that I started with and plug it in. Okay. Now, since it says round, we can use a calculator. That one I can use a calculator for. This guy here, since that's going to be my final answer, I can use a calculator there. So on the test, more than likely, they won't have you use a calculator. What they'll do is they'll just have you reduce this as far as you can go. So I'll do that in the notes just to show you how to do it, even though this is a calculator question. So you would just multiply. So I multiply these two guys, I get 16 pi. Negative 131, right? Over 16 pi. That guy's over 1. Well, 16 pi on top, 16 pi on bottom, if you're multiplying, just reduces to be 1. So you end up with just negative 131. Since it's area, it's going to be feet squared per second. And you're done. Okay. All righty. All right. Okay, so now what I want you to do is start working on that on the worksheet. Okay. I'm going to post the answer key right now to that worksheet too, so you'll have the answer key to look at. So if you want to check your answers as you go.